In this video, we'll be doing Chapter 4, Section 4, where we look at nonmetals and metalloids. You're going to need your science notebook, a pencil, and 2 colors that you haven't used yet. So either crayons or colored pencils, but you need 2 colors that you haven't used yet when labeling your periodic table. So I'm going to show you this, and then you guys can pause the video and color and get supplies if you don't have them. So what you're going to do is you're going to color everything above the stair steps orange, or, well, not orange. On mine, it's orange. On yours, it can be any color, but those are the nonmetals. And then you're going to color that last group, the noble gases, another color that you haven't used yet. And then you're going to add to your key to show what those are. And your whole periodic table, other than hydrogen, should be colored in after this. So go ahead and pause the video, get some colors, color in these 2 sections, add them to your key, and then we'll keep going. So hopefully at this point you have colored everything on your periodic table except for hydrogen. Hydrogen should have remained white, and we'll talk about why in a few minutes. So the nonmetals have so many families within them that we don't actually label them by their families when we're coloring them. We're going to just write it at the top, so you'll still need your periodic table out and you'll still need a pencil. So before we get into that, we're going to look at physical and chemical properties of nonmetals. So 10 of the 16 are gases at room temperature, meaning that they are in gas form when they are not heated or cooled. Bromine is the only nonmetal that's a liquid at room temperature. Nonmetals tend to be brittle when they're solid, which means that they're going to break really easily. They're dull, so they're not very shiny, right? They're just kind of dull or matte. They're not malleable or ductile, so they can't be formed into different shapes or pulled out into wires. And they are poor conductors of heat and electricity. Some chemical properties for nonmetals. Most of them are reactive, and so they often end up in compounds because they want to be bonded to other things. They can combine with both metals as well as nonmetals. As long as they are sharing electrons, they don't really care if it's a metal or a nonmetal. And then fluorine is the most reactive element known, and that is one of our nonmetals. So we're going to start looking at those families. So you can see here how at the top I wrote carbon family. So above that group 14, you're going to write carbon family to indicate what family it is. So carbon is incredibly important because of its role in the chemistry of life, meaning that all things that are living have chains of carbon atoms that are bonded together, making up part of them. So all living things have carbon in it. Most fuels as well that we burn for energy also contain carbon. So carbon is incredibly important in the chemistry of life. So that whole family underneath it has similar properties, and they are called the carbon family. So go ahead and make sure you label that one. The next family, called the nitrogen family, there's a theme here, right? Are we catching on that the top element is generally the name? So the nitrogen family is composed of like nitrogen, phosphorus, arsenic, and so on all the way down. The atmosphere is about 80% nitrogen gas, but nitrogen doesn't really react with other elements. So when you breathe in nitrogen, you just kind of breathe it back out. So it doesn't affect your body composition or anything of that. Nitrogen occurs in nature as a diatomic molecule, meaning that it's N2. And so it's bonded to nitrogen, atoms bonded together. And then phosphorus, which is one of the other elements in the nitrogen family, is a very reactive element. So go ahead and make sure you label the nitrogen family right above group 15. Group 16 is the oxygen family. Oxygen is all around us in the form of a diatomic molecule as well, so O2. So the oxygen that we breathe in and everything like that is all O2. When it becomes a triatomic molecule, O3, it's called ozone. So the ozone layer up at the top of the atmosphere kind of screens out harmful radiation because the radiation hits the O3s, they break apart, bond back together, and it kind of it bounces off the radiation, and so it helps protect it. Oxygen is highly reactive, and so it can combine with almost every other element, and so it wants to bond with all of the other elements. So the oxygen family is group 16. Group 17 is where that top element rule breaks. Group 17 is called the halogen family. It's not called the fluorine family. It's called the halogen family. Halogens are highly reactive, and the uncombined elements are dangerous to humans. And so all of these ones in this row are very, very dangerous when they are on their own. Fluorine is so reactive that it reacts with almost every other known substance. Even water will burn in fluorine. And so fluorine is one that has to be regulated really well. That being said, there's small percents of halogens in a lot of things that we find really useful. So like carbon and fluorine bonded together makes up like a non-stick coating. So there are trace amounts of fluorine bonded with that carbon that's on like your pans and stuff. Chlorine and sodium, NaCl, that's table salt, right? So we eat chlorine and sodium when they're bonded together. Chlorine and calcium chloride also make up ice melt for the roads that they put on the roads to help make them less icy. It melts the ice because of its chemical reaction. So go ahead and label the halogen family. The last family is the noble gases. So you can label above group 18, you're going to call the noble gases. So the noble gases are usually unreactive. All noble gases exist in Earth's atmosphere, but only in small amounts. But we also kind of channel them and use a lot of them. For example, like helium balloons contain a noble gas because they have helium. Neon lights contain a noble gas because they have neon in them. Although now most of them are LEDs, so that's not entirely true. But they used to have actual neon in them in different colors. And so that's the noble gases, which is our last family. So hydrogen, I told you we'd come back to hydrogen. Hydrogen should be the only element on your periodic table that is not colored in. Hydrogen is #forever alone. So it is the element that is the simplest and smallest. It has the least amount of particles, atoms, everything. So because it is so different than everything else, it cannot be grouped into a family. It's rarely found on Earth as a pure element, and hydrogen, most of the hydrogen that we have here on Earth is combined with oxygen to make water. But since hydrogen is so small and so different than everything else, it cannot be in any of the families, which is why we didn't color it, and it's its own element. So the metalloids have some characters of both nonmetals and metals. So when you're looking at your periodic table, the metalloids essentially fall above and below that bold line on that stair step. They're all solid at room temperature. They tend to be brittle, hard, and somewhat reactive. And their most useful property is their ability to conduct electricity. So you don't need to label these on there. You just need to know that the metalloids tend to be the up, above, and below of those stair steps that we have on our periodic table. So this wraps up lesson 4.4, where we're looking at nonmetals and metalloids.